Okay, guys, a good question. The area of a rectangular goat pen is to be 100 meters square. If the length of one side is x meters, now show that the perimeter is 2x plus 200 over x meters. Now, this is what we need to do. Solution now. Let me have a diagram. It's a rectangle, so we have it this way. Okay. So the length of one side is x meters. So let's say this side is x meters. We do not know this side, so let's make it y meters. Now, but all we know is that we're told that the area is to be 100 meters square. So from that statement, what we have is area is equals to y times x in this case, which is equals to 100 meters square. So we're done with that part. Then we're told that we should actually find an expression for the perimeter. Now, the perimeter of this is addition of all the sides, of course, y plus x plus y plus x, is going to give us 2 into x plus y. This is what we have. All right, good. Now, since we have our perimeter is equals to 2 into x plus y, we need to get our y. Now, from the expression of the area, we know that y times x is actually 100 meters square. So it means that y is equals to 100 all over x. All right. So we replace it. So therefore, p is equals to 2 into x plus, instead of y, we are going to have 100 all over x. We have it like this in bracket. When we expand further, p now becomes 2x plus 200 all over x, all right, meters. And that is exactly what we've been asked to prove, to show. That is the first part of the question. Then the second part of the question, to say, prove also that the least perimeter of the pen is 40 meters square. Now, clearly, because of the language, least perimeter is a minimum value problem. So what we need to do is this. To find the minimum value of P is to find the minimum point. Okay, so we are going to apply the knowledge of turning point. Okay, and the condition for that is the P, in this case now, by the X must be equals to 0. So it means we are going to differentiate perimeter with respect to X. Now, differentiating it, this is what you need to know. You need to know that P is actually 2x plus 200, then x raised to the power minus 1. I want to believe you understood what I just wrote now. I'm using indices, okay? So therefore, dp by dx will be equals to 2. Plus, we have our 200, then we have minus x raised to the power minus 2. This is what we have. So therefore, it's going to be 2 plus, we are going to have 200 all over minus x squared. So dp by dx is actually 2 minus 200 all over x squared. Recall, we are going to equate it to 0 so that we can find our turning point, so that we check the minimum value of x. So therefore, dp by dx, which is going to be 2 minus 200 all over x squared, is equals to 0. So we are going to have 200 over x squared is equals to 2. We have 2x squared is equals to 200. So we have x squared is equals to 100. So the x is going to be plus minus 10. That is either plus 10 or minus 10. Now, for us to know whether it is minimum or maximum, we need actually to differentiate the second time. Hence, the p by the x can be written as 2 minus 200, the x raised to power minus 2. Now, second differential, the p squared by the x squared will now give us, we have 0, then we have minus. We are going to have 200, then we have minus 2, the x raised to power minus 3. All right, so it's going to be 200x raised to power minus 3. Okay, now the condition is this: if the square p by the x squared is actually less than 0, it is the maximum point. If the square p by dx squared is greater than 0, it is the minimum point. Hence, we'll now work it out. But remember, recall x is plus 10 or minus 10. So therefore, let's test it. At x is equals to 10, the p by dx, which is going to be 200, then we are going to have 10 all raised to the power minus 3. We are going to have 200 all over 1000, which is actually equals to positive. So if it is positive, it is greater than 0, so that is the minimum point. So at x equals to x equals to 10 is a minimum point. So we all know that minus 10 will be our maximum point, so that we are going to have 200. Okay, then we have 10 raised to minus 10 raised to power minus 3, which is going to give us minus 200 all over 1000, which actually is negative. So this is our maximum point. Okay, so since we have our maximum point is at x equals to minus 10, then we have to go back. Okay, we have to go back to find our minimum value, which is p is equals to 2x plus 200 x raised to power minus 1. So we are going to have p is equals to 2x plus 200 all over x. Now, remember, we are looking for the minimum point. So the minimum point is x equals to 10. So we have p is going to be equals to 2 into 10, then plus 200 all over 10. Now our p is equals to, we are going to have 20 plus 20. So p is going to give us what? 40 meters. And that is exactly what they asked us to prove. So we've proven by finding our minimum and maximum values. Okay, so minimum value occurs at x equals to 10, and maximum value occurs at x equals to minus 10. All right, so that is how you actually need to work this question to have what you're supposed to. All right, so good. Don't forget to subscribe.